Okay, chapter 11, we're going to talk about choices. In particular, we're going to talk about how people make choices on investments. We're going to do this through something referred to as the Harry Markowitz model. It is essentially the modern portfolio theory of investing. Incorporated in that is ultimately we're going to get to a theory that's referred to as the capital asset pricing model. Now, even though we haven't specifically talked about this model before, this model is used, and we've used a formula from this model. So we're going to work our way talking about portfolios in general, how they're created, how we calculate their risk, and how we ultimately choose from a set of investment opportunities. So, to find the rate of return on a portfolio, we need to know two things. What is the weight? What is the proportion of money that's invested in each asset of the portfolio? We then also need to know what is the expected return for each of the assets in the portfolio. The return of the portfolio ultimately then is the summed product of the proportion and the rate of return on the investment. So here's an example. We have 200 shares of Disney at $30 a share, 100 shares of Coke at $40 a share. So what's the proportion of those two assets? Well, it's 60-40. $600 is invested in Disney, $4,000 is invested in Coke. So the proportions is -6 and 0.4. So what is the return? Well, the Disney earns 20% and Coca-Cola loses 5%. So the portfolio return is now 10%. And of course, after the change, there is a change in the weights. So now Disney's at 7,200, Coca-Cola's at 3,800. So the proportions changed after the price changed. If you put 10,000 in Ford and 30,000 in Tyco, you expect to get 10 and 16% for those returns. Again, what return? You can put in the dollar values here. Another thing you can do is you could just put in the weights. If I told you that you put 25% in Ford and 75% in Tyco, you can see here in the label says you can put dollars or, I can't see it there, it's hidden in the cell, dollars or weights. You can put either in those, and you'll get the answer here that the average is obviously 14.5%. So what if we had a couple of stocks? What if we have in this case we have historical data on the returns of 3 potential stocks. So here's ABC. Here are the 6 years of data that we have on these stocks. Here are the average returns. And if you notice here, these average returns are the same and the risk is the same. So each one of these stocks has equal risk and equal return. Now what we want to do is look at weights. Again, this is done on a worksheet called Stock Return and Volatility. So now if we put in, I would like to invest half of my money in A and half of my money in B. So if you do that, you'll see we're obviously going to get 10% the rate of return, but something happened to risk. Instead of, you can see that the risk of each asset is 13.42. It's not the average, it's 12.07. What if we do half B, half C? You see it even as a greater change in return. What's causing this risk? Excuse me. What's causing these changes in risk as we combine these stocks together? Well, the statistic that creates the diversification in this change is something called correlation. It measures how two stocks seem to act alike. It's a fairly simple formula. It's the covariance between the two assets divided by the product of their risks. And it can be as low as -1, or it could be as high as +1. So the correlation is stuck in between those two measures, if you will. So it turns out when you look at this statistic, you find out that between A and B, the correlation is 0.62. So it's a positive relation, but it's not +1. So as long as it's not +1, there'll be some diversification. However, between A and B, you see that it is negative 0.923. So it's not just a big number, but it's a big negative number. So we're going to get an extreme amount of diversification. And of course, you can see it went from 13.42 for each asset down to 2.79. So there is a lot less risk in portfolio 2 than in any individual asset of the three or in either of the other portfolios that we're talking about. So how can we do this? How can we find this data? Well, what they've provided with us here is some volatilities. This is standard deviations. And they've provided us with some correlations. What if you created a portfolio that had 35% in Microsoft, 20% in Dell, 25% in Ford, and 20% in Heinz? What's the risk of that portfolio? Well, if you look at these, we have what? 35% is Microsoft, Dell's 47%, Ford is 53%, and Heinz is 19%. So what happens when we combine these? Well, if we go to this particular, it's the portfolio risk worksheet, we can input the weights. Here's what we're investing in. And over here, we want the standard deviations to be from that table. So here's the variances. So how you would input these is you would put the square of 0.35. So 0.35 squared is 12.25%. So we have the variances, we have the weights, and then we add the correlations that come from the particular stocks we have. And what we'll find out is that the standard deviation of this portfolio is 26.40. And of course, as you can see, of the 4 assets that are in there, the only individual asset that has less risk is Heinz. So we have, in general, a mixture of assets that have, in general, less risk than most of the things that are individually in the portfolio. And of course, this is the concept of diversification. Now, in theory, what happens, and let me not say in theory, in reality, what happens when you create equally weighted portfolios, as you increase the number of stocks that are in your portfolio, you will see that the total volatility declines, right? There is a decrease in the total risk. But eventually, no matter how you put things together, this risk levels out and you won't get any more reduction. So the question is, how many stocks do you need to add in order to get this? Now, this appears that it's a very big number, but in reality, this isn't really to scale here. It turns out somewhere between 20 to 40 stocks, you're going to have about the least amount of risk that you can possibly get from an equally weighted, randomly chosen portfolio of investments. This is actually a study that was done not too long ago, and it basically shows, look, if total risk is going down, what is it that's going away? Why is this disappearing? And the thing that's disappearing is the diversifiable risk of the portfolio. To find the variance or the risk of a 2-asset portfolio, we have this basic formula. And this basic formula says, look, when you add 2 stocks together, each stock brings together some risk. In this case, the W's here represent the weights. This is the risk that asset A brings to this portfolio, purchased in this weight. This is the risk that B brings. Well, the question then is, what happens when we combine them in this proportion? Well, since these are squares, everything out here is a positive number. So we have W sub A is positive, WB, standard deviation, these are all positive numbers. The only thing that possibly changed then is standard deviation. What is the relationship between these two assets? If this correlation, this row here, AB, if this was 1.0, then this total amount would be as big as possible. As big as possible. But what happens if it was 0? Then this whole product then becomes 0. That should be a multiplication sign there. Sorry about that. I need to change that. But that then becomes a product of all these things, and it obviously adds up to multiplies out to be 0. On the other hand, what if it's -1? If it's -1, then this whole thing is as negative as it can possibly be, because in magnitude, correlation is as big as it can possibly be, and it has a negative sign. So we can reduce, we'd see that as correlation turns negative, we could find lower and lower correlations. Now, what we typically don't find between two stocks is we don't find typically that any two stocks are negatively correlated. They are not perfectly positively correlated. They don't have a correlation of 1, but it should be somewhere between 0 and 0.6, 0.7 in that range. So, let's move on. Let's talk about this idea or the concept of an efficient portfolio, right? The general objective in investing is to try to find stocks that are going to provide the best possible return at the lowest possible risk. If a portfolio is inefficient, it means we haven't found that stock yet. We haven't found that portfolio yet. There's another portfolio that's better than what we've already talked about in terms of both expected return and or volatility. So to identify those efficient portfolios, we want to find those things that are going to maximize return for a given level of risk. Find the lowest risk portfolio that has the highest expected return. So if we have two stocks, here we consider this portfolio is Intel and Coca-Cola. Here are some weights. Again, we're just going to invest in those two things. We're just going to invest in those two things. And we're ultimately going to find out, well, here's the return and volatility. What returns, or what would the returns of these things look like as portfolios? So here we have a dot with Coca-Cola. You see 0, 1. That means there's nothing invested in Intel and everything's invested in Coke. Up here, everything's invested in Intel and nothing's invested in Coke. And every dot in between this line, on this line then, represents an investment, a positive investment between Intel and Coca-Cola. And as you can see, there is a combination, right, that makes some sense. Why would you buy only Coca-Cola if you could go straight up here and you could increase your return and have the exact same amount of risk? Likewise, going over here, we could be reducing risk and increasing returns as we go around this turn. So up around this turn, up here, is what you would refer to as being efficient portfolios. Everything down here are inefficient portfolios. So correlation has no effect on return. It does affect volatility, though. The lower the correlation, the lower the volatility we can get to. And of course, this curve shows that portfolios in general are going to bend dependent on the degree of correlation. So if we were to change the correlations if the correlation between Coke and Intel were +1, we would have this straight line. But if correlation is less than 1, it's going to start to bend. And at the very end, if correlation were -1, we would actually have two line segments that touch out here and create a zero risk portfolio. So if two assets have a -1 correlation, you can create a portfolio that would give you zero risk, but a rate of return that's higher than the risk-free return. And of course, you know, we can't have those things. You can't have a rate of return that's greater than the risk-free return. What about different kinds of purchases? A long position is what we've been talking about so far, which is positive investment in each security. But a short position means you have a negative investment. Essentially what a short position is borrowing. You're going to sell a stock that you don't own, so you're going to get cash, and then you're going to use that cash to buy the other investment that you're talking about. Now in the future, of course, you have to buy that stock back in order to return it. So if the stock price doesn't go down, then you're going to lose money on this investment strategy. How does that affect the curves that we've been talking about? Well, the dotted lines here now represent additional investments, but in this case we're going to permit short sales. So let's not look down here per se, because those aren't good investments, they're inefficient. But as we move up in this direction, you can see that we're putting 1.2% of our 120% of our money in Intel and negative 20% in Coke. So in other words, we're borrowing Coca-Cola money, taking that Coca-Cola money and purchasing Intel stock. And what that does is, since we're borrowing, we increase risk, leverage increases risk, but we also now are able to increase the rates of returns that we can get on our portfolios. So again, what if we add a third investment, right? We have different correlations, and in this case they're saying zero correlations between all of them, right? But here's Intel, Coca-Cola, and there's this Bohr industry. We want to add that. What does the picture now look like? Well, now you can see there's combinations between Bohr and Coke. That's on this line. There's combinations between Coca-Cola and Intel, and there's combinations between Bohr and Intel. But this blue line is the relationship where we add Bohr to the portfolio that's 50% Intel and 50% Coke. So you see that we actually get some investments, we get some additional opportunities to invest when we add this other test, and you can see that the curve shifts a little bit to the left. So when we talk about these increasing portfolio size, we essentially create this bullet-shaped curve. Where on this bullet shape ultimately do we want to invest? And that's what we want to talk about before we ultimately leave this chapter. So efficient portfolios are there to give us the highest possible returns for a given level amount of volatility. It creates what's referred to as the efficient frontier. All the stocks that are on the efficient frontier are good investments. They're the ones that we would like to buy. However, we're not all going to buy the same ones. Each one of us has different sensitivities to risk. So again, the idea here is, once we have created this portfolio, and here's a portfolio with even more stocks in it, we get this curvilinear function. So how do we decide where we're going to buy investments? Well, without getting into the investment theory, where would you like to invest? Some people are going to want to invest up here because they're not very sensitive to risk. Other people are going to want to buy down here because they are very sensitive to risk. So individuals will choose something along this red line at the top. They would never choose anything on this blue line or within here, because all of these portfolios are inefficient. It's not that you're not going to make money. You'll have a return, but the deal is you can get a better portfolio by moving up to the top where the efficient frontier is. And that's part 1 of chapter 11.